Hello and welcome to Electronics with Emrys. This video is a tutorial for making a through-hole resistor in CircuitMaker. If you're a regular user of CircuitMaker and are just here for a refresher on how to build a through-hole component, then please jump ahead to this timestamp. If you're new to CircuitMaker, hang out and we'll get your first component made in no time. Before we get started, make sure you have a CircuitMaker account and you have the program installed and loaded up. It will also save you a bit of time if you go ahead and create an account on GrabCAD.com. It's not a 100% necessity, so if you're uncomfortable with that, you don't have to. But I'm going to show you how to add a 3D model to your component, and this is where I'm going to get the free 3D models from. If you need to, pause the video and we'll get started as soon as you're back. In CircuitMaker, you don't necessarily have to have a project open to create a component. But I am going to be opening up a project so that I can put the component into the project and take a look at it on a PCB. So the first thing I need to do is go to File, New Project, and then I'm going to give it a unique name. Click on Create, and then wait for the project to be created. And you can see now in my personal space that I have a tutorial file that's been created, but there's nothing else inside of here. I'm going to go ahead and right click on that file and click Add New to Project and Schematic. The default name is fine. Then I'm going to go ahead and add a PCB as well the same way. Now that I have a project to look at my component once I create it, I can go ahead and get started with the component creation. If the library is currently hidden like it is on my screen, you can go to the top, click on View, and then go to Libraries. Then you'll see it show up, maybe not in the same place as mine, but you can move this around to any part of the screen that you like or have it free-floating. CircuitMaker has a shared library, so that means that if I create a component in here, then it's going to show up for you to use, which is really fantastic and one of the things I like about CircuitMaker, but that means that for a tutorial it makes it a little bit difficult, because if I tell you to open a specific component and start working on it, you will be working on the same one as everyone else. So I'm going to do something a little bit different here. We're all going to be working on a through-hole resistor, but we're going to work on different values of the same resistor. So what I'd like you to do is go to the library search bar, type in RN55D and search. That's going to bring up a whole bunch of through-hole resistor options. Don't pick one just yet. What I'd like you to do is pick a standard resistor value and build that specific component. In this video, I'm going to be creating a 100K through-hole resistor, but you can pick any value. You could do a 12K, 120K, 150K. Basically, any number you see on this chart is a relatively standard value that you can probably find in the library for CircuitMaker. Once you've selected your component value, come over here and type in that value in addition to RN55D, then press Enter to search. And now you can see once I've selected 100K, I have far fewer components available. It doesn't really matter which of these you choose because they're all going to be basically the same thing. But I'm going to go ahead and pick the Res 100K ohm 8th watt 1% axial. And that is the part number RN55D1003FRSL. So before you actually start creating your component, please click on this to go to the Octopart website. On the Octopart website, I'd like you to copy the part number and the description. So you can just highlight this, right click, hit copy, then go to the comments section of this video and paste that information into the comments, just like this. The reason I'm asking you to do this is not because I need more comments on my videos, even though I do appreciate comments on my videos. The reason is because This system will not tell anyone else when you start editing a component. So if I start working on this component, which I'm going to do right now, I'm going to right click and go to create new component. There is no indicator to any other user that I'm making this component. So if you're doing this tutorial, I would appreciate it if you posted that information so that everyone else knows what you're working on. On top of that, once you save your component, it can take several weeks for it to show up in the system. So the entire time while we're waiting for your component to show up, other people could be making new versions of the exact same thing. That's why I think my comment section is the best way to do this, because you can look down there and see in real time if someone else is working on the same component that you want to work on. So now that you've selected a component, you're going to, just like I did, right click and click on Create New Component, and that will open the component up in a tab just like this. And assuming no one has worked on this component before, you will see Add Symbol and Add Footprint. If you see basically anything else right here, then it probably means someone else has worked on that component before. And you are welcome to keep following my advice here and edit that component and improve it, or you can close it out and open up a different one. To close out a component that you've already opened, if you go to the top, go to Home, you can click on Discard Changes just to get rid of what you've opened, and then you can go open something else if you want. Now that we have our component open, the first thing we need to create is a symbol. And the symbol is what's going to show up in our schematic. So that's going to be put into this page, and it'll look like a resistor in this case. So this is actually really simple for components like resistors. All we need to do is click on this drop down, go to New. Then at the top in the main Home ribbon, you'll see Symbol. And these are basically symbols that have already been defined for us. So I'm going to click on that, and then I'm going to go down to resistor 1. Now, if you really want to, you can use resistor 2. This is the international symbol for resistor. Personally, I like the Americanized version of the resistor symbol, so I'm going to use that one. I don't think there's a way for CircuitMaker to allow us to have two different symbols for the same component, which is too bad. It would be kind of nice if you could pick between the two. But I digress. Now that we have the symbol here, we don't have to do anything else. But I do want to show you a couple of things while we're here, just so that you know how to modify this if you want to for other components. So in a symbol, you're always going to have pins, and those pins are the connection points to your schematic. So on the left-hand side here, this is one pin for our resistor, and on the right-hand side, we have another pin. And you can tell those are black, whereas the rest of the resistor is blue. I'm using Control and mouse wheel to zoom in here so we can get a little bit of a better view. But whenever I left click on this and select this pin, and then I right click and go to Properties, I can bring up a Properties window that will show me some information about that pin. You can see the pin length, which is something that you can change. I would probably leave it at 100 mil the majority of the time. You can change the designator, and the designator is important. Whenever you go to the footprint, these need to match up, otherwise they will not connect correctly. You can change the electrical type, so if you have a pin that is an input only for a device, you can select it as that. You can call it an I/O, an output, open collector, passive. Most of the time we're probably going to stick with passive for things like resistors, capacitors, switches, and whatnot. But if you're defining a more complex device, you can choose the specific pin types with this. There are also a lot of other options, but I don't really want to go into everything for this in this particular video because we're only making a resistor, and this is a pretty quick and easy component to make. Click OK to get out of that. The actual resistor symbol here doesn't do anything. All it is a pretty picture for you to be able to see what the component is. You can really make this anything you want. If you were making something that was more specialized, you could change this symbol to make it match up to what that component is. For a resistor, we're going to just leave it alone. So right now, all I'm going to do is go to the top, click on Save All. And then I'm going to right click on the symbol and click on Close. If you thought that was too easy, you're absolutely right. Making a resistor symbol in this is insanely simple. You don't have to worry about the designator, and you don't have to worry about the part number because CircuitMaker adds those in for you automatically. If you've ever made components in other programs, a lot of the time you have to define where this text goes and the format of it and the alignment and all that stuff, but this all just gets added in for you. Don't have to worry about it. Additionally, because we're using the shared library that gets pulled from Octopart, we have a bunch of parameters for the component. So when we add this into our schematic, we'll be able to see the power dissipation and the resistance very easily. Those are things that you can add manually whenever you're placing a symbol in your schematic. You don't have to add them into the symbol here. Now we get to the actual footprint, and before we open that up, I want you to go ahead and download the 3D models. In order to do that, we're going to go to GrabCAD. I've got a link down in my description to this exact page, or you can search for through-hole resistors. The footprints we're making are set up for this specific model, so this is the one I would recommend using. It does not have color with it, which is something that doesn't really bother me, but I know it might bother other people. I actually don't know much about making 3D models for this type of component, so if you do and you want to give us extra information, please post in the comments, tell us how to add color to these. But all you're going to do is just click on download files, and you're going to have to sign in with your account, which is why I recommended getting an account at the beginning of this. Once we download the files, you can see I've already downloaded this file before. I'm just going to go to my downloads folder, and I'm going to extract this to a subfolder here so I have access to all the models. When you go in here, you'll see that there's a bunch of step files, and these are the files we're going to be using. The person that made these was nice enough to label them with the number of millimeters between the pins, as well as if it was a horizontal or vertical setup. And today in our design, we're going to build 4 footprints, and I would appreciate if you did all 4 of these because these are common, useful footprints that everyone can use once you're done with them. Now, before I click on New down here, I'm going to go ahead and click on Existing just to show you that existing doesn't really do anything. I don't know why this is, if this is a problem with me, a problem with the server, CircuitMaker, who knows. But I don't know a way to grab an existing footprint from a component using this feature of CircuitMaker. So sorry about that. If that ever does become available, I'll add a comment and pin it down below. But right now, in order to create a footprint, we're going to go to New. And once we have this new footprint window open, we can go to the top here under Home and Footprint. You can go to Footprint Properties. And I'm going to change the name of this footprint. So instead of being Vichy with the part number, I'm going to just name it 100 mil vertical. There is a height listed down here, and you are welcome to put the height of your component in, but I don't think that really does anything, so I'm going to leave it alone. Click on OK to close this out. And now we can actually start creating our component footprint. The first thing I want to do is change the grid. And this just makes it easier for me to place things correctly. So I'm going to change the grid to 100 mil. And now you can see my first through hole is going to go right here. And because I want to make a 100 mil spacing, the second one is going to go right here to the right. Before you actually start creating a footprint for any part, you should definitely open the datasheet. Now, in this case, you don't really need to. If you're doing an RN55D resistor, you can just follow along with me and the datasheet that I open. But I want to show you where I get this information from. I'm going to go to mouser.com and I'm going to enter in this part number. Press enter to search. And this one did not show up. Instead, I'm just going to search for RN55D1003. So essentially that RN55 is going to tell you the shape of the resistor. 100 are the significant figures for this resistor, and 3 is the power of 10. So this is a 100K resistor. Now you can see there's a few different options down here. I'm just going to take the FB14 version to get to the datasheet. And you'll see that these actually have the same data sheet. They're all shared. Whenever you go to the second page, it shows you what all the different part number components mean, and you can read through all that if you'd like to. Right now, I'm just going to skip ahead to the actual physical properties of the package. In this particular case, we're looking at the CMF55. You can find that out by looking back a little ways. There's a table that shows the mill style, and we're looking at RN55 from the part number. CMF55 is the global model. So coming back to this table, CMF55 has these properties. The most important thing that we're worried about is the thickness of the lead. So we want to make sure that we have a hole that's big enough to be able to fit those leads, because if it's not big enough for the lead, we won't be able to put the part into our board. In this case, the top values are in inches and the bottom are in millimeters. So this is 25 mil plus or minus 2 mil. So they're saying you should have a hole at least 27 mil in diameter. Now, I like to go with a larger hole than this because, number one, it's easier to put the component in. Number two, it's easier to desolder the component if I ever need to take the component out. And number three, if I want to put in a slightly different component, I've got a little bit of wiggle room. Now we can add a through-hole pad. Press P to place a pad, which you can also get from the Home ribbon under the Place menu, or you can right-click and go to Place, but I prefer the shortcut of P. Press Tab to get over to the Inspector, because most likely you're going to have to change some properties. The designator is 3 right now, but I actually need the designator to be 1, because anytime you create a component like this, the designators start at 1. And we saw that in the symbol editor. If you're not sure, you can double check by going to your symbol and looking at the properties of the pins. I'm going to leave the layer alone as multi-layer. Go down towards the bottom here, and you can see that the shape is round and the size is 80 mil, 80 mil. And these allow you to change the size horizontally and vertically. So for example, we could change this to be a 160 mil in one direction, and you can see how that changes the shape of the pad. But I want to keep this as 80 mil, 80 mil, and the hole size is going to be 40 mil. Now I can hear you saying 40 mil is quite a bit bigger than the 27 mil that we actually need, and there's a reason I chose 40 mil. So number one, this is basically 1 millimeter, so that's a pretty standard size. But number two, this is just big enough to be able to fit a header pin into the hole. So there are a lot of cases whenever I'm building a project board where I might want to connect a header instead of a component so that I could add in different things into that slot pretty easily. And this is one way that I can do that. And 40 may sound really big, but it's not really that large of a difference when you come down to the grand scheme of building a board like this. Now, if you went through my tutorial on using CircuitMaker to make a PCB, then you might be saying, hey, didn't you say the general rule is that you want to have your hole size to be 1/3 of your total diameter? And that is the case whenever you're making vias. But whenever it comes to making a pad to solder down to, you don't actually need the pads to be quite so big. If you do the math here, you'll find that the annular ring, the metal that goes around the edge of this hole, is already 20 mil wide, which is a pretty wide trace and a pretty good amount of area to solder to. On top of that, we're going to have solder filling in inside the hole, and solder can flow to the bottom of the board and on the pad on the bottom. So we have a huge amount of surface area to solder to here. I'm not that worried about contact. Now that I've changed the settings to what I want, I can click on the pause icon to unpause the main window here. And then I can left click right in the middle to place the first pad. And then CircuitMaker does me the favor of incrementing my designator, and I can place my second pad 100 mil away because I already set my grid to the right size. Once I have both of those placed, I can right click to get out of that mode, and we can move on to putting in the 3D body for this resistor. This time let's right click in the editor, go to Place and 3D Body. This will bring up a Choose Model dialog, and you just need to navigate to the step file that you already extracted. Remember that these values are in millimeters, so we're going to have to do a quick conversion. 2.54 millimeters is equal to 100 mil. Select the vertical 2.54 and open. And now you can see that the 3D body is attached to my cursor. Fortunately, the person who made this knew what they were doing, and they put pin number 1 exactly where your cursor is. So what we want to do is just aim where pin 1 is supposed to go and left click. Now you can right click to get out of that mode. And if you'd like to see what the 3D model looks like, all you need to do is press the number 3 and hold left shift and then right click and drag to be able to look at the 3D body. Personally, I think this is a pretty good model. Press 2 to get back to the 2D mode because we still have a little bit more to do here. The final step here is to add some silkscreen to our component. On the bottom, we need to select Top Overlay. And just to bring it up here, we're doing everything on the top side of the board, and this is the normal way to do components. When you place a component in your final design of your PCB, you can actually change the layer, and anything that was on top in this view will automatically be switched to the bottom. The only time you would use the bottom layers on a component is if you need to put something on the top of the board and the bottom of the board. But in this case, we don't need that. I'm going to change my grid size to 5 mil, and then I'm going to hold Control and mouse wheel in to zoom in a bit so that we can see this a little better. And I'm going to add an arc. You just need to left click on arc up here at the top in the ribbon. And then I'm going to press tab to change the width. So that brings me over to the left side in the inspector. I want my width of the silkscreen to actually be 5 mil. So I'm just going to press 5 and then enter. And now I have a 5 mil sized arc. I'm just going to go 2 grid squares away from the edge of the metal here. So right here, left click. And then I'm going to draw that over to right here, which is 2 grid squares away on the left side. If you try to go anywhere else, you'll see that your arc does some weird stuff. But once we place it, we can modify this arc. So then we're going to hit Escape, and we have the arc selected already. If you don't, just left click on it to get it selected. And then in the inspector, you can see some properties. The width is already 5 mil. But I want to change my angles here. Now the start angle, you can see down here, it's starting from the right-hand side of the circle, and the start angle is a number of degrees counterclockwise. So I want to go up by 30 degrees, and then at the end, I just want to have a little bit less than a full circle, so I'm going to put 330 degrees. I press enter, and that puts in exactly what I want over here. Now I can left click and I have placed in that arc. The purpose of this symbol is just to let people know which side the resistor is supposed to go on. And a lot of the time that doesn't really matter, but there are a few cases where it does. If you take a look at this 3D model, there's a lot of metal that's exposed on the right-hand side here. And in the real world, that can be a bit of a hazard. If I have the choice in the real world, I would put ground on this side of the resistor and VCC over on this side of the resistor, so that I don't have active voltages that are exposed with so much metal. Of course, that's not a requirement, that's just what I like to do. Now to finish this off, just making it look nice, I'm going to draw a line from here to here, and another line from here to here. And all that really does is just indicate to someone the resistor goes on this side and the wire comes off in this direction. Now, as far as the designator goes, that automatically gets added in, so you don't need to worry about that. If you do want to add your own designator, it's going to be a second designator, but you can do it. If you press T to add some text, and then you type in .designator just like this, then it works exactly the same way that Altium does. This designator will get replaced with whatever the designator of the component is, and it'll use the same format that you have here. But I'm not going to do that here because we don't need it. Like I said, it's already going to show up. So now this footprint is complete. All you need to do is go to the top, click on Save All. We're going to close out this tab. And you can see now that we have a symbol and a footprint. Now we're going to practice by doing the exact same thing one more time. We'll do it quite a bit faster this time, but then we'll move on to doing the horizontal footprints, and we'll slow down again for those. So let's go ahead and click on New for adding a new footprint. And this time we're going to be using the vertical 200 mil spacing or 5.08 millimeter spacing model. This is future me coming back in the editing screen to say, please don't make the same mistake I made, and make sure to name each of your footprints as you go. In here, I'm going to go to Grid, change to 100 mil, press P to add a pad, tab, and change my designator back to 1. Click back on the pause symbol, place down pad number 1, and then pad number 2 this time is not 100 mils away, but 200 mils away. Left click to place that, then right click to get out of that mode. Right click again in order to go place a 3D body. I'm just going to select the 5.08 vertical, open, left click on pin 1, hit escape, and then I'm going to press 3 in order to take a look at what that looks like, and that is exactly what I expect it to be. Perfect. Press 2 to get back to the editor. Then I'm going to change my grid to 5 mil. And I'm going to add an arc just like before. I forgot to change my layer to top overlay, but I'm just going to show that you don't necessarily have to put it on the top overlay. Now you can see that whenever I'm placing this arc and trying to place in the correct spot, it's not letting me because it's snapping to the wrong component. Now one way around that is to hold down the Alt key, and now it has disabled that snapping, and I can left click right here to place my arc. I'm going to press escape to get out of the place arc mode, and then on the left I'm going to change some properties on this arc. Now because I messed up and put it on the wrong layer, the first thing I want to do is change the layer to be the top overlay. So now it's on my silkscreen layer, and next I can put in the angles for the arc that I wanted. 30 degrees and 330 degrees. That completes the arc that I wanted. Now I want to place down a line, but before I do that, I'm going to switch to the top overlay so I don't have to do that again. Go to the top, click on line, and then I'm going to draw that line straight across, and I'm just going to leave about a 5 mil gap between the line and the solder mask edge there. Press escape to get out of that mode, and then I'm going to draw from here back across. And now that is a complete footprint. At the top, I click on Save All, right click, and close that footprint. And now you can see that I have 2 footprints available, and that was pretty quick to build. I'm going to do 2 more footprints here. One is 400 mil spacing, which is going to be the 10.16 millimeter. And then the other one is going to be 500 mil spacing, and that's 12.7 millimeter spacing. So let's go ahead and add this new footprint. Just like what we did before, I'm going to change the grid to 100 mil to make my life a little easier. Press P, tab, change my designator to 1. Then left click back over here, place the first pin. And then I need to zoom out a little bit, so hold down Control and zoom out just a little bit with the mouse wheel. And I said I wanted to do 400 mil spacing, so that's 1, 2, 3, 400 mil. Left click right here, right click to get out of that mode, then right click again, place 3D body. I'm going to select the 10.16 millimeter, open, and click on pin 1 again. Right click to get out of that mode, and of course press 3 just to double check that everything looks good, and that is exactly what I expect to see. Press 2 to get back to the editor, zoom in, and now I like to have a little bit of a different symbol on here, and in order to get this symbol right, we want to go back to the datasheet real quick. And what I'm looking for in the datasheet is value A, which is the length of the body. and value B, which is the width of the body for the resistor. And these just allow me to make a nice box that will basically line up with the resistor on my silk screen. A in this case is about 240 mil plus or minus 20, and B is 90 plus or minus 8. So in order to draw these lines, I'm going to change my grid to 10 mil and zoom in a little bit so I get to the middle of these two through-hole connection points. Switch layers to top overlay, and then select line. Personally, I like to start in the middle and have a line that is half the length. So this is 50 mil, 100 mil, and 120, which is half of the 240 body length. Then I'm going to put the exact same thing on the other side, and that's about the full length of our resistor. Our width was 90 plus or minus 8. I'm going to go ahead and make it 100 because it'll line up with my grid better. So just clicking here, then here, across to there, back up, and across to finish. And then we can hit escape to get out of that mode, select the other line I made and delete it with the delete key. I also want to add a couple of lines to the end that just indicate that wires will be coming off of here. This is one fairly standard way of doing the footprint for a resistor like this, and that is a complete footprint. Now, if you want to save yourself a little bit of effort whenever you go to create the next footprint, go ahead and select all of this, hit Control-C, and then you get a cursor. And this cursor lets you select where your copy is going to be centered on. And the best place to center it is on pin 1. Left click on pin 1, and now we have a copy of that footprint. Go ahead and save, close out of that footprint, and we'll make a new footprint. Now all we need to do is change our grid to 100 mil, press Ctrl V in order to paste, and then put pin 1 right here in the center. Now there are a couple of minor differences for this footprint. So the first one is I want pin 2 to be 100 mil wider. So this is a 500 mil spacing. Of course, the second thing is that I need my body to be different. So I'm going to delete that 3D model. And before I add back in the 3D model, I'm going to go ahead and fix the silk screen. If we go up here to grid and change it to 10 mil, zoom in a bit so we can still see our 2 pins. Then we can left click and drag to select this entire resistor body, which the body of the resistor is not going to change. It's only going to be the wires. So we're just going to take this guy and drag him over to the side until it's centered right between those 2 pins. Then we can select the left-hand wire and extend that out. Don't bring it all the way out to touch here because you don't want those to overlap. That would throw an error at you. We're going to do the same thing on the right. And now we're almost done with this footprint. All we need to do is right-click, go to Place, 3D Body, and then we'll grab that 12.7 millimeter or 500 mil spacing horizontal component. Hit Open, and then left-click on pin 1. Hit Escape, and then 3 to check our handiwork. Left shift and right mouse to drag and look at how our component appears. Looks pretty good to me. We go back to 2 to see the editor. And now all we have to do is save everything and upload it to the server. So we're going to click on the Save All Documents right here. Right click and close this. And now you can see there are 4 options for this component. Before I do anything else, I'm going to click on this little hamburger menu and click on Set Default. So now the 400 mil spacing horizontal placement is the default footprint for anyone that uses this component. And now you're done. You've created your first through-hole component. All you've got to do is click on Save to Server, and that's going to upload all of your work to the server. And it'll take a little while, but this will eventually be live for everybody to use. I think it's possible that right now, because of the holidays, they're a little bit behind because I've uploaded a couple of these recently and I haven't seen them go live at all. But typically this doesn't take all that long to get approved. So now if you want to see your component, all you need to do is at the top, instead of going to all parts, switch to favorites only, because any components you create are going to show up in your favorites before they go live on the web. I'm going to search for 100K, press enter, and you can see that now my component has that little green icon indicating that I have a real component here. So I can right click and choose place, and you can see that I have a symbol and this places down correctly. Whenever I zoom in on that, you can see that the part number is already populated and we've got R1 as the designator. I could go back and redo all of this, but I think what I'm going to do instead is show you how to fix this mistake, and I'll make some notes in the video so that you don't miss out on what I missed out on. So I made two mistakes. Number one is I didn't change the default footprint because I prefer the default footprint to be the horizontal placement. And second, I didn't name all of these. So footprint 1, 2, and 3 don't have a useful name. You can see this first one says 100 mil vertical, but the others, I don't know what the heck they are until I click on them and look at them. Of course, you can see in the 3D model what it is, but I would much prefer to have some text there that tells me. So let's go ahead and right click on this component and click on Edit. I'm going to click on this little hamburger menu and click on Set Default. So now the 400 mil spacing horizontal placement is the default footprint for anyone that uses this component. We have 400 mil, 100 mil, 200 mil, and what's left is 500 mil. Edit, Footprint, Properties, 500 mil, horizontal, hit OK, save all. Close it. Now that the names match up to what I'd like, and the default is 400 mil horizontal, which you can verify by clicking on the hamburger menu and seeing that there's no option to set it to the default. At the top, go to Save to Server, and this will get pushed as a new version to the server. And now you can see that there are two versions in my system here. The old one has the incorrect names down here and the wrong default. And then whenever I go to the second one, you can see that I've got the correct default and all of the names are in here. So I have 100 mil vertical, 200 mil vertical, and 500 mil horizontal. And if you want to place a component with any of these footprints, all you have to do is select the footprint that you want, and then right click and choose Place, and you can place in that component. It'll look exactly the same as every other component, but it'll have the right footprint. And after you've placed a component, you can also change the footprint. All you have to do, for example, I'm going to copy and paste this one as R3. And then if I right click on this and go to Properties, usually the parameters will have everything selected, but if I deselect everything and go only to footprints, then you can see that the footprint currently is 500 mil horizontal. But if I go to the drop down, I can see that there are other choices here. So I could do 200 mil vertical instead. Hit OK. And finally, now that we have these three different footprints, let's go ahead and save everything. Go to Project, update our PCB document. That's going to be adding our resistors, execute the changes, close that window, and now when we zoom out, we can see that our resistors have been added over to the side, and they have the footprints that we just created. If you press 3, you can see them on the board. And you can see that the designators were added in automatically by CircuitMaker, so that's not something we had to do in our footprint. And you can use these in your designs. Realistically, you don't have to have more than one value of resistor whenever you're doing a hobbyist level design, But it is really good if you have each of the different resistor values so that then you can place the correct one in and your bill of materials will come out correct in the schematic editor and in CircuitMaker. So now that you have created your first through-hole component in CircuitMaker, congratulations. You are now a contributor to the CircuitMaker community. I and everyone else appreciate your efforts to add components into this library because we all make use of it. Having said that, note that not everyone that makes components in here knows what they're doing. So it is a good idea to double check components if you didn't make them yourself. So if you've made it this far in the video, I want to say thank you very much for watching, and I hope you have a fantastic day.